good day mga idol. I am Angelo D. Alagos and a student from STEM 12-9. Today, we are presenting our lab experiment number 1.
Using the simulator, we were able to illustrate Coulomb's law based on our experiments and the values in our tables. The charges in the first table had a constant distance of 5 centimeters between them. We only had to change the charges of charge 1 and charge 2 to get different values. Meanwhile, in the second table, the charge values between the two charges remained constant, while the distance between the two charges varied with each trial.
In this laboratory activity 1, entitled Coulomb's Law, forces are measured at different situations given. For table A, the given condition was the distance to be held constant, while the amount of charges was agreed upon by the group. By doing so, the group assigned 5 cm r as the constant distance of the charges Q1 and Q2. With the use of PET simulator and assigning these charges manually, forces between the charges were automatically solved. For table B, on the other hand, expresses a different situation or condition in which the amount of Q1 and Q2 is held constant all throughout 5 trials. This time, the distance given between charges were assigned at different values. Then, after assigning the values of Q1, Q2, and R, along with the condition, the PET simulator identified the forces in each trial automatically.
So today, I'm going to discuss the first table and the second table in our experiment. In the first table, the distance between the charges is constant, while the amount of charges change. The value in the charges increases and decreases per trial. For the amount of charges, Q1 increases its value as the trial goes on, while Q2 decreases. The distance between the charges is 5 meters. Lastly, these are all the values of the forces between the charges. In the second table, the amount of charges is constant, while the distance between the charges change. The distance between the charges increases as the trial goes on. The value of the amount of charges in our trials is -5 and 5 nanocoulombs. In this table, it is shown that the forces between the charges decreases as the distance between the charges increases. That is all.
The Coulomb's law tells us that the electrical force between two charged particles is directly proportional to the product of the quantity of charge on the objects and inversely proportional to the square of the separation distance between the two objects. It is generally an experimental law of physics that quantifies the amount of force between two stationary, electrically charged particles. The electric force between charged bodies at rest is conventionally called electrostatic force or Coulomb force. This law has great many applications to modern life and not just to the subject areas of mathematics or specifically physics, from Xerox machines to laser printers to powder coating. The principle of linear superposition allows the extension of Coulomb's law to include any number of point charge in order to derive the force of any one point charge by a vector addition of these individual forces acting alone on that point charge.
Hi, my name is Melchor Alvaro Jr. and I was assigned in a conclusion in this laboratory experiment. And in this laboratory experiment, we understand that if we change the sign of the charge or the magnitude of the charge will be attracted or repulsed. And the electric field has both a magnitude and a direction.